Yes, thank you for reminding me. Oh, that's a lifesaver. Okay, so the idea is, I don't care how good your algorithm is, right? The idea is the more data you throw at any algorithm, the better the predictive model will become. So the idea is you need lots and lots of data. Okay. The next thing that needed to happen was computing power. So if you have to recursively calculate a million Euclidean distance a second, it requires a lot of computing power, right? It would probably melt on your own computer or your own laptop. So the idea is we've moved basically to the cloud to utilize this extra power. Because what does the cloud have? The cloud has a gigantic resource of computers, lots of computing power for us, so it can handle this surplus of data. Okay, so let's talk about the different machine learning tools out there. All right, so let's talk. So most of you guys have probably been in the realm of Excel. So let's type that. So Excel. Okay, so you can actually data mine in Excel. You can actually build things like neural networks in Excel. But the problem with Excel is that it starts to melt your computer and your laptop around 44,000 cells. And that is because Excel has a lot of overhead, right? Each cell in Excel, it's carrying other things with it, like what is the background color? Is this underlined? Is this highlighted? What kind of format is it? It's carrying lots of different things with it, and that makes it very, very bad for machine learning. Okay, so next week we'll teach you programming languages that tackle machine learning. So we'll teach you R, but you can also do data mining and machine learning in Python. So that's another popular language. So I'm more of a Python developer than an R developer myself. But just so you know, the rising popularity right now for data mining and machine learning is currently in R. Okay, you can also do things like Java and things like that, but it's not as widely used. Okay, there's also, if you're also from a university standpoint, you might have used a statistical language called MATLAB. Okay, um, but there's lots of what's called cloud-based machine learning now, right? So you have players like Big ML, Azure ML, okay, AWS ML, right? They all have ML in their name, okay? So there's lots and lots of tools out there, and a lot of people ask me which one should I use. Well, the long story short is you want to use whatever your company is using, right? So if your company is on AWS, don't go out of your way and try to pitch Azure ML, right? Unless you have to. So I would just learn whatever it is that suits you. So for the purpose of this course, we are going to choose Azure ML. Okay, so Azure ML is because, well, it's if you choose one cloud stack, you have to go all in to the cloud stack because the cloud stacks do not talk to each other very well. They integrate very well vertically, but not horizontally, if that makes sense, right? So let's take a look at one of the players, Big ML, real quick, before we get into Azure ML. All right, so Big ML. Okay, and actually just look at the Titanic. So there is a public data set out there of the Titanic passengers, and what that is it's a record of whether or not they lived or died, how much they paid when they got on the boat, what was their gender, and basically the socioeconomic status, right? And this is a model that came out of a program called Big ML. It's a cloud-based machine learning platform, and this is one of the trees that is spat out. So it's a decision tree, right? So if you're in first class and all that good stuff, and you go all the way down, and if factor filters out your age, then you, for example, live equals true. Okay, so this is an example of a predictive model, and you notice that it's very pretty. It's a very drag and drop kind of interface. Now, the reason why we don't use this one in particular is because, well, the thing about data mining is that you need the whole picture. You can't just have machine learning. Machine learning is a very small sliver of that entire pipeline, right? Because your data is piping through. You also have a data warehouse. You have a data storage. You have databases, right? You need your machine learning platform to talk to all of that. And BigML, as it is, it's basically just a standalone platform. Right? So the idea is, at the end of the day, you need the entire platform to talk to machine learning. So that's why AWS machine learning and Azure machine learning are preferable, because you can hook up those things to your data process engines like Hadoop. You can hook it up to your data ingesters. You can hook it up to your data warehouse, storage, and databases. Okay, so that's why it's important to have the entire picture together. And what I mean by the entire picture is the entire stack all working in unison. Okay, all right. So today we're talking about Azure ML, and next week Brian Johnson, will talk to you guys specifically about R programming. So this is going to be a hybrid class. When we use machine learning, we're going to use R, and we're also going to use Azure Machine Learning Studio to get it done. Now, we're going to teach it from a perspective of theory-based. So the idea is you can take the theories and the steps that we would apply in R or Azure ML and take it to any other stack, such as Python, MATLAB, AWS Machine Learning, and you'll be fine. Okay? So let's actually get into Azure ML now. So I know not all of you have an account, and that's fine. This is more supposed to be an educational webinar, and I'll give you homework after the fact so you guys can actually start practicing Azure ML. So I will just simply go to Google, okay, and just type in Azure. So Azure and Azure ML are tied together. So what it means is you need to have an Azure account. So I'm just going to type in Azure free trial, and to do that you would just click here to get into an Azure free trial page. So click try now. So when you click try now, it's going to ask you to log in, right? So once you log in, it's going to ask you for a bunch of things like your information and your credit card number and things like that. And don't worry, it's not going to charge your credit card number unless you're from, I think, China and India. It will charge you $1 for the I think it's the foreign lookup fees or something like that. All right, but other than that, you'll be fine. So once you have a free trial account, you will simply go to manage.windowsazure.com. Okay, so manage.windowsazure.com takes you to this page. So this page is the portal. So the portal has all the cloud-based apps that you can access. So this is a platform. So Azure is a cloud platform. So you can build an entire, for example, Twitter or Amazon or anything you want, basically, in this entire stack. All right, say this is true of AWS. Like all of Netflix is built on AWS. Okay, and this is true of Azure as well. So you can whatever it is you want to do business-wise with IT and infrastructure. Azure or AWS can be that infrastructure. Okay, so you notice there's a bunch of apps, and specifically one of these apps is machine learning. Okay, so there's way more tools, database, data type tools in the cloud than we can cover, but we will cover basically the basics at the bootcamp. So we'll teach you things like Hadoop, we'll teach you Azure ML, we'll teach you storage and things like that. So to get started, we need an Azure ML workspace. And if I click on machine learning, you notice that I have 3 workspaces here. Okay. Now each workspace will need its own storage account. But if I want to go to create a new workspace, I will go to new. Okay. And I will go to data services, machine learning, and then specifically I'll go to quick create. All right, so quick create will let me also go and select and name my workspace. So I can name it Fook workspace, okay? And then I will set myself as the owner of the workspace, and then I will give it a storage account. So what does the storage account do? Well, this is where you're going to store all your data, your models, basically everything. Okay, so you also want this to probably be in its own dedicated storage account. So in the future, you don't accidentally delete your storage account associated with your Azure ML workspace, or else everything will be destroyed. Okay, so basically I'm going to create my new storage account, and I will call this Fook workspace as well. So that way I know that this workspace is tied, or this storage is tied to this workspace. Okay, so I'm going to go ahead and create this workspace. Okay, and let me know if I'm going too fast. Okay. So this is how you make a workspace. So once you make a workspace, it's going to create you an Azure ML workspace in Azure. Okay, and this will take about 2 minutes to set up. Okay, and let's continue on with our machine learning tools. So a lot of you will probably also come from a SAS background, SAS. Okay, so SAS is probably one of the most powerful data mining platforms out there today, and it's probably only the oldest. Okay, it's really huge in the medical field and things like that. But the problem is it costs about $1 million. Okay, a license. So only basically companies can afford this level. But R at this point, R and Python at this point are coming into fruition. It's at the point where it's had so much open source contributions to it, to the point of where it can take on SAS just fine. And the cool thing about open source, it's free, right? So now there is a gigantic decline in SAS and a huge increase in the popularity of R and Python. Okay. Okay, so this workspace is now created, and let me just delete this one real quick. Okay, so I have a Fuke workspace here now, and if I click on Fuke workspace, it will take me to a dashboard, and there is a sign in button right here. So if I click sign in, it will lead me to a place where I can log into my workspace. And you will notice that some of you, if you're from Microsoft, you might notice that this is the old portal. There is also another portal to access Azure. So if you just Google Azure, or you just type in azure.microsoft.com and click on portal, it will take you to something that looks like this. This is called the new portal. You currently cannot create a machine learning workspace on the new portal. Okay, so make sure you go to the old portal. And to get to the old portal, you have to type in manage.windowsazure.com. Okay, so that's how you get to the old portal. So we won't be using this new portal at all for the bootcamp. Okay, it's still, I don't think it's fully ready yet. Even though it's fully released and out of beta, I don't think it's ready stability-wise yet. Okay, so it should automatically sign you in to this workspace, and you'll notice that I'm in this workspace now. So there's a few things you should look at for. Okay, so there's home. Okay, at the very top, there's home. So these are just navigation bars, right? There's studio. So the studio is what we care about, right? This is our canvas from which we will build our experiments, from which we will build our models, where we will munge our data, right? There's also a gallery, right? So this is basically their if you built a model that you really like, you can submit it to the public gallery. So this is kind of like the GitHub of Azure ML. So if you like something, you can submit it and then teach other people how you did it, and then they can clone your experiment as well, right? So I'm gonna go back. So let's look at a few things. So the studio is always what you care about. You always want to be in the studio. A new button's gonna pop up when you first log into Azure ML. Just close it. It's fine. So these are experiments. So a save file inside of Azure ML is called an experiment. So just like how when you save a Word document, right? It's a Word file, or if you save an Excel file, it's also called a spreadsheet, right? So an experiment is just a name for the saved file of your model. Okay. Then there's the idea of web services. So if you've hooked up if you've built a model and you've hooked up a web server, and now this is where your services lie, where people can call your service on the cloud. And let me show you an example of that. So if you go to demos.datasciencedojo.com, so I'm just going to paste this really big. Okay, so demos.datasciencedojo.com. You will go to a list of our demos. Okay, so if on the very bottom there's a Titanic survival predictor. Okay, so this is an example of a web service, right? We've built a predictive model that predicts whether you will live or die based upon your circumstances, right? So whether you're first class, female, and what port you embarked from. And what this is going to do is it's going to call on the back end. It's going to call a web service, and the web service is going to basically just score your model or make a prediction, right? So based upon my circumstances, I would have a 90% chance of survival, right? So by the end of the bootcamp, actually probably by Wednesday of the bootcamp, you will learn how to build the back end of this app. We won't teach you the front end, right? Because that's just HTML, CSS, JavaScript. But we will teach you how to build the model that basically powers this guy right here. So whether or not you'll live or die based upon your circumstances, based upon historical data, can we predict the future, okay, using machine learning. Okay, so this is where your web services will lie. Okay, so it looks like by just changing my port, I decrease my survival rate by 1%. Okay, all right, so let's go back to this. So there's also notebooks. So notebooks are the idea of notebooks are actually enclosed environments, right? So if you know Python, this is what the notebooks are for. And if you're more familiar with AWS machine learning, basically all of AWS machine learning is notebook, right? So if you're more used to just pure code, you would build yourself a notebook. And then there's the idea of datasets and your trained models. So trained models are basically your machine learning models that you've trained on your data, right? And if you go into settings, there's also the idea of authorizing other users into your workspace. So Azure ML is the closest thing data scientists have right now to a Google Doc. So if you want to work on a team, on a machine learning project or a data science project or an ETL project or a batch processing project, You would actually just make yourself a workspace and invite all your coworkers into the workspace, and then you can work on it together. I think that is phenomenal. Okay. All right. So let's jump right in. So we will now create an experiment. So if you click on New, and then New will let you create a few things. So you can import data from a local file right here. Right, so you can import from a local file and choose whether it's a CSV, TSV, and whether or not it has headers, or whether or not you want to overwrite an existing data set. Okay. You can also create a new experiment. So I think we will do that now. So you notice that we can create a blank experiment, or they have a bunch of other example files you can choose. So if you don't know how to do things like image recognition, then you can just simply search in image, right? Or actually, I think it's called digit recognition. But yeah, but you get the idea. All right, so the idea is we'll just make a blank experiment. So a blank experiment has basically nothing in it right now, and so this is actually the workspace that you'll be working with. Okay, so if you look on the left, these are all our available modules. So modules are basically tools or functions that we can use, and on the bottom you will see a bunch of controls. Right. All right, so if you click on Save Datasets, it already comes with a bunch of sample data. Okay, so if you just drag in a data set, you notice that it's a drag and drop kind of usability, right? So if you can drag it around. So the entirety of the data set is represented by this node thingy, this module. Okay, so these are called modules. So you notice that we don't care how big or how wide or how many gigabytes this data is. It's just encapsulated. So if you ever worked with things like data flow diagrams, this translates very, very well to data flow diagrams. So all the outputs are going to be on this node right here. So this module right here, if you want to see what it can do, what this node is outputting, right? So this node is outputting some kind of data, right? So if you mouse over it, it says data set. Okay, so that's its data type. It's a CSV. So if I mouse over it and I right click on it, I can visualize. So you notice I can visualize the data. So you notice that this is not too big of a data set. It's a 205 row data set, and it has 26 columns. Okay, so this is automobile pricing data. Okay, so you notice that, yeah, the entirety of the data is right here. We can load it into a notebook too. So if you're more used to Python or Python 2 or Python 3, you can do that as well. So if you're more used to AWS machine learning, this is exactly how you would do it. You can also download the data set. So if I click download, it will give me a file where I can download the file. So that may or may not be preferable, because remember why we're in the cloud in the first place. We probably have too much data, and it probably will not fit in our laptops or our computers. So the idea is, if you're probably using this, you've probably outscaled your computer already. Okay, so the idea of working with big data. Okay, so now that we have data, what do we want to do with it? Well, we can do lots of things with it. There's lots and lots of other functions we can do here. So let's look at format conversions. Okay, so if we want to save this data set, we can just drag in a convert to CSV module, right? Or if we're not happy with CSV, we can save it to as a TSV, right? So if I connect it, right, so now I have two workflows, right? So you can see one workflow going into here, one workflow going here. So on one side, I'll get a CSV, and on one side, I'll get a TSV. So if I run this right now, right, so you notice I have to run the experiment to execute the functions, because right now these are just blank instructions. So once they have a check mark, it means that there's something in it. There's something cached in this module, right? So if I right-click on it, I can now save it as a CSV, or I can save it as a TSV. So this is going to become very important on Thursday, when you guys will create your own models and output a batch processing file of its predictions. Okay. Now you can also do other things too. You can also do ingress and egress, which is a really fancy, just a really fancy term for reading in data and writing out data. Okay, so let's see what this can do. Okay, so I can read it from a blob storage. So a blob storage, that's just a really fancy name for just cloud storage. So if you've ever used Google Drive or OneDrive or Dropbox, this is that, but on steroids. So Azure Blob, I think by default comes with 200 terabytes, and I think it's a 1/10 of a penny for a gig for a month. So you can't really beat those rates. All right. So AWS in AWS, this is it's called S3. So if you're more used to S3, this is the same thing. Okay. So you can also connect to a SQL Server, So if you're more used to SQL, right, and it's in SQL, you can do that as well. You can also read in from a Hive query. So Hive is Hadoop, right? So if you have a Hadoop cluster running, well, and you have a Hive table, well, now you can query the Hive table directly without even downloading the file and re-uploading the file, because that takes some time as well. Or you can read just straight up from an HTTPS. If you just do www. I think CNN here, it will just crawl and scrape CNN.com. Okay, but if you want to just read in data, so I'm just going to go to Google and Google UCI dataset iris. Okay, so this is a Hello World dataset. Okay, so all I did was Google UCI dataset iris. Okay, and this takes me to the iris dataset. So this is the Hello World dataset of machine learning. And if I actually want to look at the raw data, so I'll go to data folders and then iris.data. So you see that this is the raw data just posted on a web link, right? So I can just copy this web link, right, and paste it in to this HTTP crawler. And then it's a CSV, and does it have headers? No, it does not have headers, so I'm not going to check this box. Okay, so now I can just run this model, and it's going to go and it's going to crawl this web page right here, and it's hopefully going to parse this data for us. Okay, all right, so let's look at that. So this is going to read it in. It's going to create us a schema. All right, so whether this column is numeric and things like that. All right, so it looks like it read it in. So if I right-click on the output, I can now visualize. Okay, so you notice that it didn't know what headers it are, so it just made it column 1, 2, 3, 4, 5, right? So, and look, our data is now loaded in to Azure, right? So, and we can now visualize our data too. So we can see that there's equal numbers of iris, versicolor, Retosa, and Virginica. Okay, so there's 3 unique values and there's 1 missing value, right? And I think the 1 missing value is an extra row that got pulled in and it had nothing in it. Okay, so now that it's in here, right, I can save it as a data set, right? So I'll say this as iris ingress or something like that, right? And if I save it, it's going to save it to my workspace. So you notice that if it's a reader module, it can't cache it. So if I run this again, it's going to go ahead and go to this website and parse this all over again. Okay? Now that's going to be really useful for a web scraping perspective because web pages change often, but this is a data set, right? This is a static and eternal data set. It's not going to change. So it's going to be a waste if it's going to parse it in every time. So that's why we're saving it as a data set, right? So if I look under my saved data sets now, I will have an iris ingress that I just pulled in. You guys see that now, right? So again, I can also just convert it to a TSV from a CSV and just run this again, right? So this is gonna be all right. So this is so you guys notice that it's a drag and drop version of machine learning, right? So now I can also write data, right? So even though I just read in data, I can write data out to other things as well. Right, so for example, if I want to write it out to a blob storage, right, for long-term storage, if I want to write it back into Hadoop or into Hadoop, I can do that as well. So you notice here I can do some crazy things from an ETL perspective, right? I can write in from one Hadoop cluster and write out to another Hadoop cluster with transformations and maybe predictive modeling in between. Okay, same with SQL Server. Okay, so all right, so what else can we do? Okay, so let's look at this. So let's look at some things that we might want to do. So if I drag in this automobile pricing data, okay, and I visualize it, so there's lots of things wrong with this data set. There's a lot of things that probably need to be cleaned, right? And that's just called pre-processing, right? Because machine learning models only accepts clean data. So every machine learning model out there accepts clean data. And how you clean that data will determine the success or fail of your model. Okay, so let's take a look at some things, right? So let's look at symboling. Okay, so in symboling, yes.
Okay, sorry to interrupt. I'm not sure if it's just me, but I'm having a hard time following what we're trying to do. Are you trying to give us an introduction to all the features of the Azure ML Studio and as a pre-session want us to just learn how, what are the different capabilities, or
Yeah.
I'm not sure if it's going too fast
So
for me. I'm definitely feeling it's too fast.
yeah. So what we're gonna do so we're gonna use Azure ML for rapid prototyping of models at the bootcamp. Okay.
Okay.
So I want you guys to get more or less used to the interface and basically the modules that you'll be using at the bootcamp, right? Because we'll be building models in like 15 minutes to 2 hours per model,
Okay.
right? So the idea is
Okay.
I don't want you guys to get confused because of the interface or anything like that, okay?
Okay.
So the idea is I want you to get used to the interface. Like, all right, now I need to drop a column. How do I do that? All right, I drag
Okay.
in this module. Now that I need to clean this data, what do? All right, I'll drag in this module. Okay, so it has a lot of capabilities, and so it's of course it's going to be a little bit of a learning curve, right?
Sure.
But not as much of a learning curve as teaching you guys R. Okay, so
Okay.
R is a full programming language. So if this is your first time going into machine learning, without any knowledge of programming, well, now you have to juggle learning two things, right? You have to juggle learning programming, you juggle syntax, you're juggling the machine learning theory, and you're trying to juggle the math as well. And that's going to become really, really hard. So that's why we use Azure ML sometimes as a proxy, right? Because sometimes we just want to split the data. We don't care to multiply our indexes by 0.75 and then try to filter out all the indexes that weren't in that 0.75, right? Sometimes we want to just type in split and drag in this guy, right? And then this will split the data for us. So the idea is this is going to be a drag and drop way to approach machine learning. And from a teaching perspective, this is amazing, right? Because you don't have to juggle syntax and programming and math at the same time. You just have to juggle the ideas behind machine learning, the theory behind data modeling and data machine learning.
Okay. So we'll have to be a little up to speed in terms of this interface, right?
Yep.
I mean, the Azure ML Studio. And yeah, I mean, I think if you could even suggest resources in terms of what we could use before the actual bootcamp,
Yeah, so
to get up to speed on this, that will help.
So everything that we're going to use to get up to speed actually is in these webinars. So everything I teach you today is completely relevant to what you're going to see at the bootcamp. Okay, same thing with the R. So we'll give you homework for Azure ML, and we'll also give you homework for R programming as well. Okay.
Okay. Okay.
All right. So going back into that. All right. So we look at this data, right? So this data has some things with it. So now we have to do what's called pre-processing, right? Where we clean our data, we conform our data, we make it really nice and clean for our models. All right, so we look at this. So there's a column here called symboling, okay? And we notice that it has only 6 unique values. All right, so that probably tells us that it's probably not a numeric feature. And also you notice that it's all very clean integer-based numbers. Okay, so that probably tells me that, hey, this can probably be a categorical value. All right, so what does a categorical value mean? So it's things that look like numbers, but aren't numbers, right? So some good examples of that are let's look at that, right? So categorical values, right? So would you say zip code should be treated as a number? Should we take the mean zip code? Should we?
No.
Whose mic is on? Oh, there we go. All right. All right. So if you look at zip code, right? Should zip code be treated as a numeric value? Right? Can we take the min of zip code? Can we take the max of zip code? Can we average it? All that good stuff. We probably wouldn't, right? Because a zip code is more or less a placeholder, right? It's a distinct value, right? It's what's called categorical value. So a good example to test whether or not something's categorical is can we evenly put it into one bin or another bin, right? Are you alive or are you dead, right? Are you pregnant or are you not pregnant? Are you is the stock going to go up? Is the stock going to go down? All right, so those are examples of things that can be expressed in numbers, but in this case, probably shouldn't be treated as numbers. They should be treated as distinct values or categorical values. Okay, so let's look at that. So in this case, It's going to be treated as, it's right now it's treated as a numeric feature. So what does that mean?
Hey, a quick
Yeah.
question.
Yeah.
So are zip codes categorical values?
Yeah, zip codes are categorical values.
But they do not, like one zip code to the next one, like assuming 98052 and 98053, they have no relationship. Like I was thinking, like, when it comes to sizes, for example, small, medium, large, those are categorical values.
Yes, so small, medium, large are categorical values as well. However, they're a separate type of categorical value. They're what's called ordinal categorical values. So ordinal means there is some kind of ordering to them. There is to get to one, you have to get to the other. Like, for example, single, married, divorce, right? That is an example of a categorical value that has some kind of ordering. You can't have one without the other. If you're divorced, it has information in there because I know that you were single first, and then I knew that you were married to result in the divorce. Does that make sense?
Yeah. And does the same apply to zip codes?
For the most part, no. It does in some cases, some states, but for the most part, it's basically just incremented up by one. It's almost like a primary key in a database, if you think about it that way. So if whenever you need something new, like a new record of something, you would increment the database by one in the key, and then that's your new zip code. Basically, is how that is formed.
Sure, thanks.
Yep. All right. So this symboling thing probably should be treated as a categorical value, right? So we want them to be treated as distinct and independent choices that could have been made. Okay? Does that make sense to everyone here? All right. So if we look at the next column, it's normalized losses, right? So normalized, what does normalized mean? It means we standardize the data, right? And then losses, well, let's take a look at this. Well, this probably tells us, this right here, this distribution right here tells us that, hey, this can probably be treated as a number, right? And if we look at text, right, anytime we see text, if we see text, it probably means that it's either a string or a categorical value, right? There's no in between there. There's no chance of it being numeric. All right, so if it is a string, now you have to ask yourself, is it an actual string or a categorical value? And how you can tell that is how many unique values does it have, right? So how many unique values? If it doesn't have too many unique values, then that probably tells you that, hey, this can probably be made categorical. All right, so a good example of a categorical value that has a lot of different values is countries, right? There's like 300 countries out there. There's 50 states, right? Yes, those are going to have a lot of unique values. Right, but not enough so that they're all unique, right? It's not going to be in a situation where, for example, your name, right? Mohan and Sharon and things like that. Yeah, there's going to be a lot of duplicate Sharons, but at the end of the day, right? If you combine your first, middle, and last name, they're independent, right? They're kind of like pseudo keys for each person, okay? So in this case, we should make categorical as well. We should make field type categorical because there's only two values here. So there's two distinct values, right? Diesel and gas. And also, okay, so we also look at this and there's two values in their aspiration, right? So number of doors, okay? So there's only two values and now look, there's some missing value here, right? So how a computer treats null is it will break, okay? So if you ever tried to divide by 0, it will break, but 0 is there's still something there to divide by. There's still a number there. But how do you divide by the absence of a number, right? So how do you add the absence of something, right? So the idea is you always need to have missing values filled in, okay? Plugging in the holes, if you will. Okay, so we'll do that in a little bit as well. If you also look at this, there's also only 5 unique values, so we'll make that categorical as well. This should also be categorical. There's 3 unique values, 2 unique values, 53 unique values. So yeah, so we're probably approaching the upper limits of what should be a unique value. But if you look at this even further, it has decimals, right? So usually categorical numbers have to be whole number integers, right? So in this case, we should probably keep this guy numeric. Even though there's only 53 unique values, yes, it looks like there is some kind of scaling happening here with numbers. So we should keep this numeric. This is also decimal, so we should keep these 4 guys decimals or numerics, okay? Weight, right? So we look at weight, there's a distribution here. So yeah, let's keep that a number. So there's a string here and there's a string here, and there's only 7 unique values and 7 unique values respectively. So we can convert these guys to categorical as well, Okay, so let's keep track of which columns we want to make categorical. Okay, so and let's get even further. Okay, so there is a data mining framework that we should go by, right? So once you get in data, that should be your first step. Now what you want to do is you want to clean the data, right? So before that though, you want to do what's called data exploration, but you also want to do what's called cleaning the data. And there's many steps to cleaning the data, okay? So there is categorical casting, okay? So you want to explicitly tell the computer that these values should be treated as distinct values or independent choices that could have been made, okay, and not treated as numbers. Another thing you want to do is filter out strings, right? So you want to drop strings because there's nothing the computer can do with that. Or you can also transform the string. So when we get to our text processing unit in our boot camp, we will talk about how do we take things like a Twitter message and turn them into something graphical that the computer can actually crunch, okay? And then we want to do things like clean missing data, okay? So let's look at that. So right now, what are we doing? We're finding columns that can be made categorical, okay? So let's keep track of that, okay? So in this case, I have a column called symboling, okay? Make. So these should be made categorical. Okay, field type, aspiration. All right. Let's see, number of doors. There we go. So number of doors, and then there's body style, drive wheels. So also you notice that when we're doing categorical casting, this is not just an Azure ML. This is in every machine learning platform. So if you're data mining in Excel, if you are data mining in anywhere else, you will have to do these categorical casting. So in R, well, you'll learn next week that you will convert these things to what's called factors. So factors are how you explicitly call something a categorical value in R. Okay, so engine type. Okay. Number of cylinders. So if we look at this too, if number of cylinders was also written out explicitly in 1, 2, 3, 4, 5, 6, right? That can actually be made into numbers, right? So right now it's what's called an ordinal categorical value. So we can actually just assign the number 4 to the digit 4, right? So in that case, there can be a range there, right? Because if you have 5 cylinders, I know that you have 4, 3, 2, and 1 cylinders respectively. Okay. All right. So let's see, engine type. Oh, I already wrote that down. All right. So what else should be made categorical? So there's also some kind of fuel system, right? And then bore and stroke, we can probably keep that as numerics. Okay, horsepower, compression, peak RPM, city MPG, and all that stuff. And right now, we are trying to predict this guy. All right, so price will be our what we're trying to predict, right? And then everything else will be our predictors. Okay, so this is called the response class, and these are called predictors. Okay, so based upon this entire data set, can we guess? Based upon the statistics of the car, can we guess the price of the car? Okay, so at the bootcamp you'll be learning how to do that. All right. So for the purpose of this this webinar, I'll just get as deep as how do we clean and process data? Okay. So how do we make things categorical? Okay. Well, let's look at this. If I type in something called metadata editor, and by the way, you notice that there's lots and lots of tools in Azure ML, right? If I looked through all of them, I would probably go mad if I wanted to look for anything at all, right? So there's this nice search bar here, okay? So today I'm going to teach you something called the metadata editor. And this is a really important module in Azure because it allows us to edit the schema or the metadata of our data, okay? So what does that mean? So if I click on this, on the right-hand side, there should be a toolbar. So if you don't see it, there should be this bar right here. And what this does is now we can change our data columns, right? So we can launch what's called the column selectors. So this is going to apply a transformation, And now I want to ask, and now it's asking, what do you want to apply the transformations to? Well, I want to apply the transformations to everything I consider to be a categorical value, right? So I have a nice and handy list right here, right? So in this case, if I click on this, by the way, so sometimes when you get into this, it won't autocomplete for you right away. So if I just visualize, okay, if I visualize, oh no, if I click on this and expand this toolbar, there's a column selector, and if I launch it, you notice that there's no autocomplete at first. You have to click out of it and then click back into it, and now there's autocomplete. Okay, this is really handy, right? Because now you can just point and click. So I will make symboling, make field type, aspiration, all right, number of doors, body style, drive wheel, engine location, engine type, number of cylinders, and fuel system. All right, these are the columns that I want to apply a transformation to. Okay, so you notice that I could have done this many ways, right? So I began with no columns. So I want to begin with no columns and include only these columns. Okay, so I can include them by column indices or column types or names as well, right? But if I check this, now whatever transformations I make in this module will be applied to these columns. And I want to go down here. There's a categorical thing right here, right? So I want to make them into categorical values. So if I run this, now it's going to go ahead and transform my data, and it's going to make my columns into categorical. Okay. And if I look at this, if I look at it before, right? See, also there's another example here. So number of doors, that should probably be converted into 2 and 4 digits respectively, rather than categorical values. Okay. All right. So if I look at the output of the metadata editor, okay, now we can, I mouse over it now, I can now see that now symboling is now a categorical feature. And you notice that there are now discrete values on the bar chart, right? On the bar chart, now it's 0 and 1. There is no possibility of a 0.5 symboling, right? This is important when you express your categorical features in terms of zeros and ones, right? So an example of that is pregnant, not pregnant, right? 1 representing pregnant, 0 representing not pregnant, right? So there is no such thing as maybe half pregnant, okay? So you can't have 0.5 pregnancy, okay? It has to be 1 or a 0. So if I look at the original data set, when it was treated as numerics, you notice that there is the idea of a 0.5 symboling. There's the idea of negative 0.5 symboling as well. Okay? So now that they've been conformed into categorical values, you can see that visualizations start to appear now. Right? So if I click on any column, a visualization appears. So it's either going to be a box plot or a histogram. Okay, so if I compare a categorical value to, let's say, make here. So make is a normalized loss. Okay, so that's a numeric feature. By the way, so a feature is just the name of a column. Okay, so each column is what's known as a feature in machine learning. So if I click on symboling, and I want to compare how symboling compares to normalized losses, right? We get box plots for each categorical value of symboling, right? Just for example, if I want to see the price of 2-door cars versus 4-door cars, you can see that now I have a box plot, and I can now log the box plot so I can see it much clearer. All right, so from this alone, I can tell that for the most part, 2-door cars tend to be cheaper than 4-door cars. Okay, maybe it's because they're smaller. I don't know. Okay, so if you compare a numeric value to a categorical value, which is what I just did, right? So price is numeric and number of doors is categorical right now. So you see a box plot comparison of each categorical value for each associated numerics. Okay, but if I compare 2 numerics against each other, so if I want to just see what is the let's see, the length of the car in relation to the price of the car. So these are 2 numeric columns that I'm comparing to one another. So if I go down here, now we get a scatter plot. So we see that there's some kind of exponential curve here, right? So as the car gets longer, it gets exponentially more expensive. Okay. If I compare 2 categorical values together, like front wheel drive and maybe what's a good one here? So if I compare front wheel or the wheel drive to maybe the field type. Okay. Where is the field type? I'll get a grid. Okay, so I get a grid that looks kind of like this, and I wish they were expressed in percentages, but hey, we get color codings. All right, so that's that. So now that everything is casted correctly, now this is the part where we can do data visualization. So if you're from a more traditional, like kind of BI and data analysis role, right, we're building reports and things like that, right, and you're building reports in R, you're building reports in Python, right, everything needs to be converted categorical first. Same with Azure ML. Okay, now that we have that, we have to plug in missing data, right? So how do we do that? So there is something called the descriptive statistics module. So I'll go to the top left hand corner and I'll just type in descriptive statistics. I'll drag it in. All right, so now if I run this module, it's going to give me what? Just summary statistics. What's the first quartile range? What's the second quartile range? The median, the max, the min, the unique values, and everything in the between. But specifically, I care about the number of missing values, right? So I could have gone through individually and selected each column one at a time and see if it has missing values. So this one has 44 missing values, this one has 0, this one has 0, but that's very tedious. And gigantic data sets, you don't really have the luxury. If it's a 1600 column data set, you don't have the luxury of just doing that. Okay, so there's a cool module here that just summarizes what has missing value. So I can see that normalized loss has a missing value. Bore and stroke and horsepower and peak RPM and price also have missing values. So I'm just going to write that down real quick. So normalized losses, number of doors. Okay, and then I have a bore, I have a stroke, I have horsepower, I have peak RPM, and then I also have price. So price has missing values as well. So that's also a problem. Okay, because remember, price is what we're trying to predict, right? So if what we're trying to predict is missing, well, basically the whole row is going to probably be lost. So we'll look at that in a little bit. All right, so in this case, all right, so let's explore these columns and see what they are. So if I go back to my metadata editor, so remember the metadata editor has my data set that's been transformed. The descriptive statistics only outputs a table of the summary of statistics, okay? So I can visualize the output of my metadata editor now. Okay, so you can see that. All right, so we look at normalized losses. So normalized losses is a numeric feature, okay? So I should write that down, right? Because how you treat missing values differs whether it's numeric, categorical, or string. Okay, and we'll get into that as this goes on. So let's also look for the number of doors. So the number of doors is a categorical, right? So it's a categorical. All right. So what else do? We're also missing things in bore. Okay. So bore has 4 missing values. So this is numeric, and stroke is also numeric. I can just tell because it has decimals here. Horsepower, that's probably numeric as well, right? Because that's represented in a number. All right. So peak RPM, that's also numeric. Okay. And then we also have price, which is a problem because it's our response class. Okay. We're trying to predict price, and we're missing values of price here. Okay. So let's look at this. So what do we want to do? So in regards to clean missing data, there is a clean missing data module. So if I just type in clean, drag in clean missing data. All right. So now I have a module that is just designed to scrub data. Now I have to treat numeric scrubs separately from categorical scrubbing. Okay. So let's talk about missing data for a minute. Missing data. Okay. All right. So when I'm cleansing missing data, I have two types of data, right? I have numerics and I have categorical, and they're going to be treated separately and differently as far as their transformations are. So numerics, I have a lot of versatility with, right? Because I can fill in missing gaps in my data with things like the median, the mean, the mode, the min, the max. I can, of course, I can drop the entire row. I can drop the entire column. I can build some kind of regression model, right? Some kind of statistical model. So I can do things like Pearson's correlation or things like that. Or I can just build another predictive model. So I can build a predictive model that would predict, for example, based upon the vehicle's price and all its good stuff, can I predict its normalized loss? I can fill in the missing values that way as well. Okay? But when it comes to categorical values, I only really have a few choices, right? Because you can't really do math on categorical values, right? Because now that brings things out like the median, the mean, the min, the max. But I still have the mode available to me, right? The mode is the most common type. Right? So if I look at this, if I go back and it looks like number of doors was categorical, right? So if it looks like the number of doors is categorical, well, the mode right now is 4 doors, right? So 4 doors is the most popular choice. So in that case, if I replaced it with the mode, the missing data with mode, anytime where we saw null, whose mic is that? Can we? All right. So anytime where you see missing value for the number of doors, it will be replaced with a 4 door. Okay, does everyone understand that? So if this column, or if this right here, right, this is a null right here for the number of doors. If we clean missing data with the mode, now a 4 would now be introduced right here, right? And yes, we are changing our data, right? And does anyone have a problem with replacing data with other parts of data? You should, because we're trying to predict based upon basically the circumstances of the car, the data about the car. Can we predict the price? But if we're altering the data by replacing it with the mode, right, now we have maybe fabricated data. But let's talk about what happens if we don't fill it in with the mode. If we don't fill it in with the mode, well, machine learning won't accept it in the first place. Okay, so we should all agree that machine learning should still happen. Okay, because we want this predictive model to predict price. Okay, so what are we giving up? Well, we add in a 4 right here that wasn't there before, and we don't know if this is the actual answer, right? Because we're just filling it in so that the model will accept, the machine learning model will accept it. So the mode, what is the mode going to do? Well, it's going to start overloading this column right here. So 4, now it's now going to have 2 extra things on it that it didn't have before. Okay, so now we're altering a little bit of our distribution. All right, so the histogram is going to change. Okay, let's look at, for example, bore. Okay, so if we replaced bore with something like the median, right? Now our distribution is actually going to raise up around the middle, right? So around 3.31, it's going to raise up a little bit. Okay, but the cool thing about the median is our box plots don't change, right? So if we switch this to a box plot, okay, this bar in the middle represents the median, and if we replace the median, if we replace the missing values with the median, well, this bar would not change. It would stay exactly where it is. The only difference is the more missing values you have, the smaller this box plot's going to become, right? So it's going to make your box plot smaller. So it's going to just pull in the distribution towards the median, okay? And you really have to evaluate whether or not that's going to have an adverse effect on your data. And we will explore that for at least 2 to 4 hours at the bootcamp. But for now, I just wanted to show you guys how to clean missing data in Azure ML, if that's okay. All right, so what do we have? We have numerics and we have categorical. So we only have one categorical value. So let's take care of that first. So that seems easy. So I have a column selector. All right, so I have a module here that's trying to do a transformation, and then I have a column selector. Okay. So if I click on this column selector, it's going to ask me, well, what columns do you want to change? So and you notice that it's going to begin with all columns. It's going to try to clean every column at the same time. But if you remember, we should probably separate our transformations between numerics and non-numerics, right? Because if I did a blanket transformation and I said everything that's missing converted to the mode, well, that'd be fine if we wanted our numeric values to be the mode, but in this case, you know, let's keep it separate so we can have that kind of versatility. Well, I'll begin with no columns, and I'm going to choose individual columns to include. So what column do I want to include? I want to include the number of doors. So the number of doors is a categorical value. So if I click on the number of doors here and check that, okay? Now there's the idea of a cleaning mode, right? I can do things like the mode, right? And then also I can do a custom substitution value. So what is that? So if I go back to my missing data module, I can do the mode. I can substitute. Okay, so what does substitute mean? It means that I'm going to go ahead and for every missing value, I'm going to fill in my own value. And I'm going to define that value. It's just going to be a static value every time. So if I look at this, if I look at symboling, which no missing values, number of doors, right? If number of doors, where there's a missing value, if I set my own missing value, let's say if all missing values, I will substitute with the word blank, right? Now there's going to be 3 categorical features to act upon. There's 4, 2, and blank as going to be a separate third categorical choice, right? So you notice what I'm doing. If I did that, I'd be separating out my data, right? Not my categorical features, right? So if you have a lot of missing data for categorical values, that's a good idea, right? But in this case, I only have 2 missing values. So if I only have 2 missing values, in the grand scheme of things, I do not want to go ahead and create a separate categorical value just for the sake of capturing null. I want to just go ahead and throw them all into 4, which is the mode, right? So yes, you can do substitution, okay? You can also build a predictive model as well to predict categorical values. Right. You can also do statistic modeling. So we won't get into that much, this so much. And you can drop the row. You can also drop the column. Okay. So let's look at that real quick. So sure, we can drop the row. We can certainly drop it. So if you look at the number of doors, okay, 2 missing values. There is a missing value right here. Okay. We can go ahead and drop this entire row. Okay. And out of 204 rows, sure, that's not that much. But the idea is there's still good data here, right? There's good data on these other 25 columns. These other 25 columns are behaving, and it's still good, right? If we got rid of this row, now we're punishing every other column for this one column's bad behavior, right? So the idea is you want to just plug in this gap, and you don't want to just rip out the gap, okay? So in this case, the number of doors, which is a categorical value, I'm going to replace it with the mode, okay? All right, so I'm going to go ahead and run this. And it's going to go through and it's going to clean the number of doors column. So now the number of doors column should not have any missing data in it any longer. Okay, so let's look at our other guys. So numerics, all right? So we have lots of options here. We're probably going to go with the median. Okay, so of course there's lots of theories on which one you can go with. You can go into mean, min, max, and all that good stuff as well. Okay, all right. So if I look at this, clean missing data. All right. If I look at the number of doors now, you'll notice that there's no more missing values. Okay, so now it's either 4 or 2. So basically, it took all of our data that was missing and made it a 4. Okay, so we're going to go ahead and do that with numerics too, except we're going to convert it to numeric. So you can also copy and paste in Azure ML. So if I select this module, I do Control-C, and then I can do Control-V, and hey, look, I have another one, right? And I can go ahead and connect this module. And you notice that this clean missing data has a separate output. You can ignore this output. You'll never use it. Just care that your clean data is always going to come out of the left node. Okay. So if I click on this clean missing data, okay. Now what do I want to do? I have lots of missing data here. All right. So if I look at here, I have lots of columns that are numeric. Okay, so I will add my numerics into the pile. So right, I can begin with no columns, and I can include, okay, normalized losses, okay, bore. Oh, I really should this was alphabetical. Stroke, horsepower, peak RPM, right, and price. Okay, actually let's not include price, and I'll explain why in a little bit. Okay. Okay, so bore, stroke, horsepower, peak RPM. Is that right? 1, 2, 3, 4, 5. All right, I have 5 values. All right, so you notice that it's going to go through and it's going to select these 5 columns, and we're going to replace them with the median. Okay, so we'll go ahead and run this. And by the way, you guys see this window down here? You can disable this this preview window, this navigation window by just clicking this button down here. Okay. So that does tend to get in the way sometimes if you have a smaller laptop screen. Okay. So now that it's gone out of the clean missing data, I can now visualize it. All right. All right. So what else can we do here? All right. So our data is outputted, and it doesn't look like much has changed, but we have cleaned missing data. We have cleaned the missing data. So how do we see that? Well, we take this descriptive statistics module. We can just copy and paste it and attach it down here. Right? If there are no missing data, this descriptive statistics module will have a column with all zeros in it under missing values. Okay? And you notice that there's a check mark here. All right, so these check marks mean that this module is already run and there are no changes. So it's going to go ahead and call the server and skip this module. It's going to call the server and skip this module, call the server and skip this module. And you notice that it finished all at once, right? So that's the cool thing about this is that it's cached, right? So when you run through things like in R, it's going to run through the entire script from the beginning until the end, unless you specify the individual lines that you would want to run, okay? So in this case, let's visualize the descriptive statistics. So we look at the missing value count column. We scroll down and everything is clean except price. Okay? So what do we want to do about price? Well, price just happens to be what we're trying to predict. Right? And if we filled in missing data for price, now that's a predictive model, isn't it? Right? That's what we're trying to build this entire model to educate the computer on how to predict price based upon the aspects of a car. Now, if we filled in our own data right here, well, now we're distorting the model. We're adding unnecessary noise to the outcome of the model, right? So I hate to say it, but we actually have to drop these rows, right? Even though 26 other columns behaved correctly, because price is our response class, this column is too important to distort. Okay, so now what we have to do is we need another clean missing data module to apply a separate transformation on price. So let's click on price. All right, and I want to X out all of these guys. And when I see price, whenever this thing sees price, I'm going to go ahead and tell it to remove the entire row. Okay, so I'll go ahead and run that. Okay, so if you come from a place where you're getting labeled data, so if you've ever collected labeled data before, you'll know that it's very expensive to acquire labeled data, because usually a human has to sit there and they have to score the data, right? So by dropping that, we actually lost maybe quite a bit of money. Okay, so we lost 4 rows. So we had 205 rows. Now we're down to 201 rows, but we have no more missing values, right? All right, let's get into some other things too. So if that was just one data set, right? So this data set's fully clean and it's ready for machine learning. Okay, so I can save this. So by the way, every time you hit run, it does a save, and there's the idea of a run history right here. So if you dramatically mess something up, you can actually go back to a prior revision. For example, this is where I just had the metadata editor, right? So I can go back to the actual revision right now, right, and look at it. Okay. All right, so that was one example of one. Okay, now there's also, let's look at another data set real quick. So there is a data set called the adult census income. There's some things wrong with this data set as well. Okay, so okay, so there is a column here. Actually, let's actually look at the Titanic data. Actually, this is a bad example. Let's look at the Titanic data. So I'm going to actually go to a different workspace. So you notice that I can go to different workspaces, right? I can have multiple workspaces. That is completely fine. Okay? So if I go into this, this workspace has a bunch of saved things for me already. Okay? So can everyone still see my screen? Or is it just Mohan?
Yes, I can see.
Okay. Mohan, can you try to rejoin? That might fix it. Okay. So in this case, I'm just gonna go to new. Just create a new experiment real quick. So in this, I've preloaded in a dataset called the Titanic dataset. So you'll be working with dataset a lot for your homework, and also during the boot camp. Okay, so if I just visualize this data set real quick, there is this column right here. Okay, so there's a column called name. Okay, so it's a string, right? This is an example of a string because it has 891 unique values out of 891 rows. So every single row of name is completely unique, right? We also have something called passenger ID, right? Which is also completely unique, 891 unique values and 891 rows, right? If we built a predictive model out of just passenger ID and we let the predictive model run long enough, it can accurately predict from passenger ID whether or not someone will live or die. But there's no value to that because you will never see that key again. For example, the primary key of 3, you will never see this key again because this database, if it's a primary key, it's going to iterate in a way so that everything is going to be unique forever, so that every row will always just be unique, right? So this column, passenger ID, holds no value to us from the perspective of predictive modeling, and name in its current form holds no value. Now, of course, you can do lots of transformations to name. You can do things like pull out the titles, right? Mr. and Doctor and Commodore and Junior, right? And that might have predictive power, but right now as a string, this has no predictive power. Ticket also looks like it's going to be a string too. Lots of different strings in there, and it doesn't look like we know how this was derived either, right? So in this case, we want to go ahead and drop passenger ID. Right? So how do we drop columns in Azure ML? So there is the idea of a project columns module, right? So if we click this, we will project columns, right? So if I click this and connect this here, these are the columns. So project columns are we want to project out the columns that we want to keep or drop. Does that make sense here? So what does that mean? So if I can launch the column selector, okay, and I can begin with all columns and exclude, right? So what does that mean? So all columns means I want to bring forward all 12 columns, right? So if I look back at here, there are 12 columns, okay? If I look at project columns, I can now exclude passenger ID, name, and ticket, right? Because these things right now hold no predictive power for us. And if I go ahead and run that, it's going to go ahead and drop those 3 columns. Now, the other thing about the column selector is I can do the opposite as well, right? So if I look at this, I selected 3 columns to drop, and you notice that now I have 9 columns left. So I am now rid of those useless columns. Okay. So
a question.
Yeah.
Yeah. Okay. So when you drop a column, it'll drop from the source, or it'll drop at the next tab.
It'll drop at the next step, right? So if I look at my original source back at the data set, it's actually still there, right? We still have 12 columns. We still have name and passenger ID. But as the data went through into this workflow, it went out of here and got transformed, and this is the result of the transformation of this project columns right here. Okay?
Okay.
Now, I could have also done it in reverse in terms of the column selector, right? So you notice that I selected columns to exclude, but I can also select columns to include, right? So what does that mean? Well, I can begin with... Yeah, go ahead.
Yeah, no, I was just saying you're going to put the name of all the columns here that we want, right?
Yeah, so I can just pick the columns of the names that I want, but that's going to be a lot of work, right? Because I have to pick survive, G-class, sex, age, sibling, spouse, parch, fare, cabin, and embarked, right? And why am I showing you this? Well, there are data sets where, if I look at, for example, the adult census income data set, okay? There are columns. If you notice this, there's age, education number, capital gain, capital loss, hours per week. Those are the only 5 categorical values in this data set, right? So if I went ahead and I said I want to convert things to categorical, when only 4 of them need to remain numerics, in this case I will select the columns that I want to exclude from the transformation, right? So if I want to convert everything except age, FNL weight, education number, and capital gain, capital loss, and hours per week, right? And you notice I only need to select 6 columns rather than selecting the other 13 columns just to make categorical, right? So basically these it's going to bring forward all columns and exclude these columns from the transformation. Right? So that's another way of doing it. Okay? All right. So now if we look back at this, Azure ML also supports SQL transformations, right? So if I go back here, right, I can type SQL into here, right? So this is T1, this is T2, this is T3, and I would refer to them in here, right? And now I can just, if you're more used to SQL transformations, now you can do where age is greater than 25, for example. And then you can simply run it, and it would filter out everywhere there's age that's greater than 25. So if you're more used to SQL transformations, if you're used to things like case when statements, you can totally do that in here as well. So you notice that it filtered out, there's 891 rows, now there's only 412 because those guys were not greater than age 25, right? So if you look in here, there's no one below the age of 25, right? Everyone's 25 or above, right? So you can do a SQL transformation. Now this also supports R. So if you type in something called an execute R script and drag it in, you can type R into here now. Okay, so there are situations where Azure ML is faster. There are situations where R is faster. So that's why you want to use a hybrid approach to both, right? So for example, if you wanted to do things like pull out the titles, right? You want a column of whether or not they had a title, where Mr. and then Mrs. and then Junior and things like that, right? If you wanted to just pull it out into its own column, you'd probably either use R or Python, right? So it supports both R and Python. And then you want to type in things like regex in here, okay, using R or Python, and it would have it extract that way, okay? So light data transformations, Azure ML can handle. Heavier transformations like text processing, you will probably have to rely more on R and Python. Now, you can totally do a hybrid approach. And I totally recommend a hybrid approach. So you can use Azure ML for a bit, then pause, do a bit of R transformations, then pause and do Azure ML. It's perfectly fine. Okay. Now, there's lots and lots of things in Azure ML, but for the purposes of the bootcamp, that's all you need to know for now. Okay. So I will send you guys out with some homework. Okay, and I think it's on the learning portal. So if I go to portal.datasciencedojo.com and I just log in. Does everyone here have a portal account now, right? Oh.
No, we don't. I don't have it. I don't know.
No, we don't have.
Trying to create one?
Yeah. Did you not get an email recently about logging in, creating a portal account? Okay.
Not that I recall of.
Okay, we will resend another invitation today. But if you didn't get that invitation, for now, go to portal.datasciencedojo.com. All the webinars that we host will be on this portal. So the post-webinar bootcamps, the pre-webinar bootcamps, and our homeworks that we have during the bootcamp and before the bootcamp, they'll be on this portal as well. Right? So if I go into this and I look at my class called Bootcamp, right? This is where, hey, this is where my course is, right? So I have the fundamentals of data engineering and R and all that stuff. So if I look at that, the webinar we did today was Intro to Cloud Computing and Azure ML. Okay? So if I click on this, okay? All right. Usually instantly if it's a business day. Okay. So if you request an account today, it's usually instant if it's during business hours because we have to be there to approve your account. But other than that, it's to the next business day. So if you sent a invitation over the weekend, we may or may not be on. Okay. So for example, the webinar post will be here. Okay. So yes.
Where we need to send the request? What ID?
So just go to portal.datasciencedojo.com and register for an account. So portal.datasciencedojo.com and register for an account. And you notice that the webinar video that we have is posted here. And you notice that there's also two homeworks, right? Intro to Azure ML Part A and Intro to Azure ML Part B. All right. So if I just click on that, that should open for me a PDF. Okay. And right here is, I think, 27 pages of homework for you guys. So please complete this by, I think, Tuesday of the bootcamp. Okay. So on Tuesday of the bootcamp, we will continue where we left off from this homework. So we will build a predictive model and deploy it using what you've done in the homework. Okay? All right. And also, I didn't really talk about the cloud computing as much, but let me just go back into this and find a more complex experiment. All right, so here's an example of an experiment that, it's a little bit more complex. Yeah, so the homework. So basically, you want to just go through the course one by one, right? So you want to start on getting started, right? Fill out this survey, then go to the next lesson, right? And then this takes you to the first webinar, right? And then there is the slide. So this one doesn't have homework, so I'm just gonna mark it as complete. Okay. All right. So I've gone through this first webinar, and I'm gonna go through the next lesson, right? So we will fix that right now. So we had to change the webinars, but basically on the right side there's an intro to cloud computing and Azure ML on the right side. All right. So intro to Azure ML is what you're looking for. Okay. All right. So if I look at this seems like a complex model, right? So if I run this should take a little bit of time to build a model and do all the cleaning and the scrubbing of the data, right? But while it does that, I can just totally close this experiment, right? And it's fine. It's still running because it's in the cloud, right? So that's the cool thing about cloud computing is it's probably always going to run whether or not you're there or not. And another cool thing about being in the cloud is parallel processing. Now, it's not distributed, so if you're more used to Hadoop, this isn't distributed, but it can actively work in parallel. All right, so if you look at this, there's two workflows, right? So once this dependency has been solved, these two modules can actually independently run of each other. And actually, each module you see is going to be run on a separate computer. Yeah, send us an email, Brad, and we will help you out. Okay? Or follow me up at the end of the webinar. Actually, I'll put Brian on, and he'll help you out. Okay? He's in charge of the learning portal. Okay? All right. So if I look at this, yeah. So this is an example where if I run this, this side's going to run in parallel, and this side's going to run in parallel, because they are not dependent on each other any longer. And actually, each module that you see, right, each of these widget modules that you see is actually being run on a separate computer. And each of those computers are 64 gigs of RAM instances, right? So that's huge, right? So if you look at your own laptop might have 8 gigs of RAM, right? So if you talk about computing power, yes, this is the next scale beyond that. So it's very useful to actually just have this run. And the idea of machine learning, well, I used to do a lot of machine learning in Excel, a lot of machine learning in R on my own computer. And maybe some models might take 3 hours to run, right? So basically, when I build a model in R and it takes 3 hours to run, I have to leave my computer there, and it's basically just crippled for the next 3 hours trying to solve this problem. Now, if it's in the cloud, it's someone else's problem, right? You can just close this window and come back, and it'll be done when it's done. Okay, so I travel a lot to do these boot camps, so if I have a project that I know it's going to take a long time to train, I just fire off the project and then I get on the plane. Then when I get off the plane, hey, it's done, right? I didn't have to deal with it, right? I didn't have to leave my computer on, okay? And for the most part, you cannot configure what kind of VMs Azure ML will use. So we'll talk about at the bootcamp on either Monday or Friday on how to scale beyond this. Okay, so the idea is you work in Excel and then you outscale Excel and you go into R, you outscale your own computer in R, then you go to Azure ML or AWS Machine Learning, you outscale that. Well, if you outscale that, now you have to actually spin up your own VM. So in Azure and AWS, you can spin up your own virtual machine, right? So virtual machine is basically a computer in the cloud that you're controlling. You have your name on it. It's your computer. You're renting it out. You're renting it like you're renting a car. Okay, so the idea is you can spin up a virtual machine, and you can spin up a virtual machine with 32 cores and 448 gigabytes of memory. So this is what's available at the consumer level. You can also shoot Azure or Microsoft a support ticket and tell them, hey, I need a 2 terabyte RAM instance machine. Yes, they have those. So if you got a 2 terabyte data set, that can totally still work on one computer. Okay, and then we can teach you, well, we will teach you how to scale even further than that. So if you have really big data beyond things like 2 terabytes, well, then you're going into distributed computing settings, and that's just Hadoop. And we will teach you Hadoop. Okay? All right. Does anyone have any questions for me? That concludes the Azure ML webinar. To summarize it, long story short, the modules that you really want to work with is the metadata editor. So the metadata editor is what changes the metadata, the schema, and it does the categorical casting for you. You can also rename columns in here as well. Okay? To drop columns, you want to use something called the project columns module. That's what's going to let you drop or keep columns. Okay? And to clean missing data, well, there's a clean missing data module. Okay? So if I type in clean missing data, so these are the 3 modules for the most part, is what you will be charged with learning.
So once we create the login, are we going to have all data sets up there already, or we have to bring them from somewhere?
So the homework actually tells you how to bring in the data set that you're working with. So if I look at Intro to Azure ML Part A, and I scroll all the way down. Okay, so on page 76 of this, it will tell you that you need to actually go to this data set and read it in, right? And that's about it. All right, so if I just copy this. Oh. Grr. Okay. If I copy this and just paste it into that HTTPS reader that you saw earlier, it will give you that data set. All right, so it walks you through very pretty pictures, right? Picture tutorial. So yeah, just follow it, and you'll be good. Okay. And David, you said I would imagine that a 64 gigabyte VM is pricey. Yes, a VM is pricey, but the cool thing is you're not actually renting a VM. You're using a cloud service. All right. So let's actually look at the price of this. So Azure ML, Azure price calculator. So if you ever want to know how much any of these things cost, you just Google Azure price calculator or AWS price calculator, and it tells you, right? So virtual machines are very expensive, yes, but Azure ML itself is not expensive. So if I look at computing, I think it's under data, analytics. Okay, and there's machine learning right here. All right, so if I look at machine learning, I can look at my compute instance, right? So in this case, I have 1 seat, so that's going to be $10 a month. Okay, but how many experiment hours am I going to run? Let's say I took a model and it took me 3 hours to train. All right, there is your price. To train a 3-hour model, it took me $3. Okay, so it's actually very, very affordable. So if I compare that to things like a virtual machine, right? If I look at a virtual machine, actually this is where it starts getting very dicey. Okay, so if I get what is this? Oh, well, I guess it's bugging out right now, so I can't really see it. But I think it's like $5 a day or something for a virtual machine. But again, you are renting a high performance compute machine from the cloud, so that's all it is to it. And when you shut down a VM, you're not charged for it, so just always keep that in mind. All right. Any other questions for me while I'm here?
No, I'm good, thanks.
All right. And if you need further support from me, shoot me an email.